Welcome everyone. I am Sudipto Pramanik and I will be talking about principle of superposition today, which is a very basic concept for circuit analysis and widely used in both DC and AC circuits. This is the outline I will follow for this lecture. First thing first, the first question that arises is what is superposition theorem? Superposition theorem basically states that the voltage across or the current through an element for a linear circuit is the algebraic sum of the voltages across or current through that element due to each independent source active at a time. So, for example, if we consider this circuit where there is two independent source, one is the voltage source Vs equals to 120 volt, and the other is the current source Is equals to 12 ampere. Both the independent sources are present in this circuit, and let's suppose we are wanting to determine this current, the current through the 6 ohm resistor. So if we determine the current through these resistors for the voltage source 120 volt acting alone, and then current source 12 ampere acting alone, and if we calculate this contribution, these two contributions, first the contribution of Vs equals to 120 volt, that is I1 bar through the 6 ohm resistor, and secondly the contribution for the current source, I1 double bar through the 6 ohm resistor, and then we can apply the principle of superposition to calculate the net current, that is I1 bar plus I1 double bar. So basically the current through the 6 ohm resistor is the current taking the independent sources one at a time. First the voltage source and then the current source. Next, as we are telling that we will take one independent source at a time and we'll deactivate the other sources. So what does that mean? So if we back to this circuit and let's say we are keeping the voltage source Vs active, and we will deactivate the current source, and similarly we will keep the current source active and we will deactivate the voltage source. So at a time we will keep a voltage independent source active, and we'll deactivate the all the other independent sources. So basically we are deactivating two types of sources. One is voltage source, independent voltage source, and the other one is obviously the current source. So deactivating a voltage source, or we can say that we are turning off the voltage source, meaning that we'll have zero voltage at that place. So if we deactivate this voltage source, we'll telling that we are having a 0 volt here. So 0 volt basically represents short circuit. So 0 volt is we can replace the 0 volt as short circuit, and we'll deactivate the voltage source in this manner. Similarly, let's say we are deactivating a current source. So for a current source, if the current, if we turn off the source, that is the current will be 0 ampere, and 0 ampere basically represents open circuit. So we can replace the current source, independent current source, by open circuit. So having known what deactivating sources actually means, now let explore them in the circuit. So here there is two independent sources. One is 120 volt and the other is 12 ampere, that we are already discussing and have discussed in the first slide, in fact. So we are telling that we'll keep the 120 volt at one time, and we'll deactivate the 12 ampere current source at that time. So 12 ampere to deactivate the 12 ampere current source, where we have known that we have to open this part. So for calculating the contribution of 120 volt, we are just replacing the current source by open circuit, and then we will analyze this circuit to find out the I1 bar. And similarly, for the calculating the contribution of current source, we are replacing the voltage source. That is, here is the voltage source that we are replacing by a short circuit, and similarly we will analyze this circuit to determine this current I1 double bar. So when we get I1 bar and I1 double bar, we can simply apply superposition theorem, or the theorem of addition, to determine the net current I1, that is I1 bar plus I1 double bar. So, as we have already discussed all the concepts of superposition theorem and how to deal with them, let's explore the theorem in a actual circuit. So, look here, we have again one voltage source and one current source, and we're wanting to determine the voltage across the 4 ohm resistor. So first we are telling that the voltage across this 4 ohm resistor will be the algebraic sum of two voltage components, that is contribution of Vs acting alone and the contribution of current source Is acting alone. So with the concepts we have already discussed, we are replacing the current source when we are keeping the voltage source active, and we are replacing the voltage source when we are keeping the current source active. And for the voltage source acting alone, the voltage across the 4 ohm resistor, that is V1, we can calculate this V1 by applying voltage divider. That is, the voltage across 4 ohm resistors will be simply 4 by 4 plus 8 into total voltage, which is basically 6 volt. So we can say that 4 by 12 into 6 volts. So this is basically 2 volt. Similarly, for the current source acting alone, we can calculate the voltage across 4 ohm V2 by the multiplying the current along the 4 ohm resistor and the resistance itself. So for calculating the current, we can apply current divider rule here, and thus we can calculate the current by 8 by 8 plus 4 into 3 ampere. So this is the current, and we're multiplying this by resistor value. So we are getting here 8 volt. After calculating, we will get here 8 volts. So when the voltage source acting alone, we are getting 2 volt, and when the current source acting alone, we are getting 8 volt. And the principle of superposition tells that the net voltage will be summation of these two voltages, V1 plus V2. So 2 volt plus 8 volt equals to 10 volt. Okay, now we are wanting to know that when and why will apply superposition theorem. So the first case, or the first fact, is so obvious that when we are applying superposition theorem for many circuits, the analysis becomes so simple, and the calculation becomes easy. So for example, for this circuit, we can calculate the contribution of 12 volt and 5 ampere just by seeing it, and by calculating it in our mind. For example, when the voltage source will active only and current source will be deactive, we can just see the circuit that the voltage here is basically 2 by 2 plus 3 plus 5 into 12 volt. So that is 2 by 10 into 12 volt. And just by calculating it in your mind, we can get the value, which is uh, 12 by 5. So we can know that this is approximately 2.4 volt. And similarly, for 5 ohm 5 ohm current source acting alone, we can calculate the voltage across the 2 ohm resistor. So, in that sense, superposition theorem is the calculation or the analysis of a circuit. And more importantly, from my perspective or my experience, I can say that superposition theorem is actually more effective for AC circuit where there is multiple frequency sources. For example, here for the current source, the frequency is 5 radian per second, and for here the uh, angular frequency is 2 radian per second. So when there are multi-frequency circuits, let's think that we will calculate the voltage across 1 ohm by simply by applying phasor analysis. But the phasor analysis only deals with the magnitude and the phase. For example, for a voltage source, we can express it as V and the phase, and similarly for a current source, that is the value and the or the magnitude and the phase. But what I am trying to draw the attention that the phasor doesn't consider the frequency omega. So if we calculate this circuit uh, taking both the phasor of voltage source and current source, and then apply the or taking all the phasors of all terms and converting them in this resistance and capacitance in frequency domain, and then applying the phasor analysis, we can get a value of VO. But the problem is the voltage of this source and this sorry, the frequency of this source are different, so we can't do that simply. So what I will have to do that I will have to apply superposition theorem. So I will show the analysis here. So I am taking the superposition theorem here, and will tell that the voltage across the 1 ohm resistor that we are going to determine can be calculated by taking the contribution of each sources acting alone. And when we are taking these sources acting alone, for example, for the case of DC, there will be no problem, and for the two AC sources, we can simply calculate or analyze the circuit separately, and taking them back into a time domain after calculating everything in the phasor domain, and then we can just add the contribution of these three sources. So the problem of analyzing the three portions of the circuits, that is the contribution of three independent sources, can be solved with the help of superposition here. And just look at here that the contribution also has corresponding frequency, so it is not creating a problem anymore. So having known all the advantages and all the application of superposition theorem, we will talk about the limitation of superposition theorem also to make the complete analysis of this topic. So first, superposition theorem is applicable to linear circuits only. For example, if in a circuit, if there is a diode transistor, which is basically where the current and voltage, suppose where the current and voltage, for example, for diode, we know that uh, there is a relation like that, uh, that is the current and voltage are not linear. So in that case, superposition theorem will not be applicable, because superposition theorem uh, actually is based on the concept of linear circuit and linearity. Next, superposition theorem is not applicable for power. Superposition theorem is applicable for only voltage and current. This is because power is, as per this equation, power is uh, proportional to I square, or it is proportional to V square. That is, power is not linear with the current, and also power is not linear with the voltage. Rather, power is related to the I square or V square. So current square or voltage square. So as the superposition theorem is applicable for current and voltage, simply it will not be applicable for the power. Next, superposition theorem can be time consuming if there is too many sources. For example, think that there are 10 independent sources. 10 independent sources. So let's think there are six voltage sources, four current sources, and we're wanting to take all the contributions of them separately. And so we have to analyze the circuit 10 times, keeping one independent source active at a time. This will be so much complex and time consuming. So this will not be a good idea to apply the superposition theorem in a circuit where there is too many independent sources. Okay, that's all to discuss today. And with the end, I want to give credit to the contents that that has helped me to build the slide and to present this topic to you nicely. Thank you everyone for listening and keeping the track. Thanks.